me start with the Database Management System, or DBMS. So DBMS is a collection of interrelated data and a set of programs to access those data. So I have a figure here to explain the database management system. So the primary goal of the DBMS is actually to provide a way to store and retrieve database information that is both convenient and efficient. So the DBMS is meant to support database applications na usually in two modes. The first mode is data analytics mode, and the second mode, which is more common, is the online transaction processing mode. So we have here several database application examples. So ano ba yung mga applications na gumagamit ng databases? Yung mga businesses, they needed a system to store their company information. So ano yung mga common, regardless of the industry? Ito yung three common departments in a business. So meron sales, merong accounting, or finance, and then merong HR. So for the sales, they needed a system to store customer information, yung lahat ng products nila, yung mga purchases. And then for accounting system naman, of course, the finance part, yung mga payments, the receipts, and then yung mga assets ng company. And then for a company, they needed a system to store yung information about their employees, yung salaries na kanilang employees, and yung mga payroll taxes. So another example is for manufacturing naman. So for manufacturing, information that they needed to store are something related to management of production, mga inventory ng orders, and supply chain. So yung third example natin is for banking and finance. So for banking and finance, ito yung mas common sa atin because we have bank accounts. So the banks store customer information. So ito yung mga accounts mo, and then it also they also needed a system to store yung mga listahan ng mga loans and all of the banking transactions for all the accounts. And then for some, they have credit card transactions, and then sales and purchases of some financial instruments like stocks, bonds, and real-time market data. Another example is for universities. So sa universities naman, these universities needed a system to store information about the enrollment, so yung sa registration, and then for student grades, student information, etc. Ano pa yung mga other examples? So for airlines naman, so for example, like PAL, Cebu Pacific, AirAsia, they needed a system to store sino yung mga nagpa-reserve, ano yung mga schedule ng mga flights, yung mga open pa na seats, and so on. And then, yung mga applications na customer-facing for airlines, sila din yung mga nag-access ng mga ganitong information. For telecommunication naman, the recording of calls, texts, the data usage regarding dun sa parang, let's say, prepaid or postpaid account, sometimes they needed for example, like for postpaid accounts, they needed this information to generate the monthly bills. For those naman na they needed customer support, and sometimes they call the customer service. They record all the calls so that they know if the issues are resolved or pending pa. And then, in general, we have web-based services. So yung mga web apps running on the internet. So one main example is for online retailers. So yung mga e-commerce sites. So they needed a system to track or to store yung mga order mga orders, yung laman ng cart, so that they can use this information for them to customize yung mga recommendation systems nila. Sometimes, yung mga online advertisements din na lumalabas on the website. So, they needed a system to store those products that they needed to advertise. There are other systems that are utilizing document databases. So, for example, if I publish a paper, there are parang publishers that store the books, the papers, and they are stored in a document database. And each of the document have properties like, of course, may ID siya, may keywords, may topic, may abstract, and so on. So, on a case-to-case basis, sometimes mas appropriate yung document databases compared to transactional databases. Another example ay navigation systems. So, they needed a system to store to store locations of various places of interest along with the exact routes of roads, train systems, and buses, etc. So, yung mga web or applications like Google Maps, what else? Waze. Sila yung mga gumagamit ng database din, and then they store those information in a database system. So, ano ba exactly yung purpose ng database system? Before I answer this question, in the early days, database applications were built directly on top of file systems. So, bakit file systems? Because before, of course, you wanted to have a persistent way to store the data. Hindi katulad nung parang if we program a particular code and then we declare the variables. Kapag namatay yung machine, nawawala na yung information na yun. Not unless it is stored in a file. So, yung mga certain applications nangangailangan mag-store and retrieve data uses file systems directly. So, wala silang tinatawag na database management system. However, maraming problems kapag ganun yung ginawang setup. Meron tayong mga problems na listed dito at naka-highlight siya in pink. So, first issue is nagkakaroon tayo ng data redundancy and inconsistency because data is stored in multiple file formats, and these file formats are causing duplication of information in different files. At the same time, it also introduces difficulty in accessing the data. So, for example, if document-based tapos file system yung ginagamit to store those documents, suppose in a university, meron ka nung student record, and suppose you need a list of all the students, you need to go through every file, and you need to write a new program to carry out each of the new tasks. Ang main reason din ito is because those files have probably different formats. Pwedeng, of course, it is composed of multiple files. Ito rin yung reason why it is difficult to access data. It's because it has data isolation. Other problem is integrity problem. So, using a file system, it is difficult to enforce a certain constraint about the data. So, for example, yung account balance dapat greater than 0. It becomes buried in the program code rather than being stated explicitly. So, it's hard to add new constraints or change existing ones kapag ginamit na siya, let's say, in the previous versions of the files. So, yung last three issues naman is about atomicity, concurrent access, and security problems. So, yung atomicity naman of updates, Ano ba muna yung atomicity? Atomic operations, meaning sila yung mga set of operations na either mangyayari or not at all. Yung mga ganitong types of operations na kinakailangan ng mga database applications, necessary na maging all or nothing because of some instances na hindi maiiwasan. For example, like failures may leave database in an inconsistent state with partial updates carried out. So, yung pinaka crucial na example dito ay, suppose magta-transfer ka ng fund from one account to another, dapat mangyari siya ng buo na parang nabawasan ka, malalagay sa iba, or not at all. Kesa maputol siya sa gitna na pag-transfer ka na, tapos hindi niya na-receive. So, yung ganong type ng operation or condition ay kayang makapture ng atomicity in a database application na directly to file, hindi mo magagaranti na may atomicity yung mga operations. What else? So, yung current, kapag multiple users na, yung nangangailangan ng concurrent access to the database, may mga nag-arise na performance issues. So, isa pa ay uncontrolled concurrent accesses can lead to inconsistencies kapag file systems lang yung ginamit natin. And then, it's also difficult to ensure yung security or yung access rights permission ng per user. Although in the file system, meron naman yung parang way to identify kung ano yung parang specific access ng particular user, yun ay user-based pero hindi siya with respect to a user role. So on a per user account, nag-a-apply yung file system-based. So dahil may mga ganitong reasons, kaya nagkaroon ng database system kasi it provides or offers solution to all of the mentioned problems. Okay, so yung next topic naman natin is about data models. So yung data models natin, you can think of this as abstraction or it answers yung underlying structure ng data. So this data models can be a collection of tools that describes the data itself, the relationships between the data, the meaning of the data, and the constraints we set to the data. So may mga different types of data models which is highlighted in this rectangle. So yung sa week 2, i-discuss natin yung mga relational model, which is basically type of a database na mukhang table. So it is actually a collection of tables to represent the data and relationships. So yung relation dito is the table. For week 5 naman, we will be sharing with you the entity relationship data model that is mainly used for designing a database. And then we also have other data models na object-based. So this is very similar to your struct model, tapos classes, and then may mga instances of the object. So in this particular model, it covers yung mga object-oriented and object relational models. So for week 8 naman, we will be sharing with you yung mga types ng data model na somehow may structure. So, magtatawag nating semi-structured data model yung mga yon. And one of the most common types of those data are written in formats like XML or JSON. So, ito yung mga may certain structure, pero inside the particular parang segment of that structure, it can be unstructured. So I call it tree-like structure of unstructured data, or could be free texts. And this is commonly used especially for for web-based applications. So for week 9 naman, we will be discussing other models. So yung mga models na to ay may mga hindi na lang tree-like structure, but graph-like structure. So dito natin madidiscuss yung mga graph databases and so on. So let's discuss the relational model. Ano nga ba yung relational model? As I mentioned before, all the data is stored in various tables. So this example is actually a tabular data in the relational model. So this example is the instructor table. The instructor is a relation, and it is defined using the columns and rows. So yung columns dito are the the ID, name, department name, and salary. And the column names should be unique with some naming conventions na dapat i-follow. And then the rows naman is the number of parang information. So each row represents a piece of information. So yung nag-invento ng relational model is actually Ted Codd, Turing Award din noong 1981. And then after the relational model, which is the theoretical basis of all the relational based mga table-like databases, ito yung naging basis nila, yung result ni Ted Codd. So minsan tinatawag na mga tall tables kapag sobrang daming rows, and then kapag sobrang dami namang columns, we call it wide table. So yung mga recent technology ng Google na meant for analytics, they are dealing with wide tables, or sinasabi nila mga big tables. Okay. So this is a sample relational database. So a database contains one or more relations, or one or more tables. So in this case, the relational database contains two tables, the instructor table and the department table. And usually they have common columns to relate one table and to the other. So in this example, we have the department name as the common column ng dalawang tables na to. So let's look at the instructor table muna. So meron siyang ID, name, department name, and salary. So one piece of information is that Einstein with an ID 22222 is in physics department. So ito yung department name niya, and yung salary niya, let's say, is 95,000. So if you go to the department table, of course dapat mag-exist si physics na department dito sa department table, and you can also include more information about this department, like for example the building, the budget, etc. So you can have information about the department where Einstein belongs to. So this is a simple example of a relational database. So yung next topic naman natin is about the view of data. And yung view of data is, as I mentioned a while ago, it explains then yung structure of the data in three levels. So we have the physical level, which is the lowest level. It answers how the data is stored in memory storages, yung actual physical location nung data na yon. So it could be the block of consecutive bytes, ganyan, na nandito sa specific hard disk na to. And then for the logical level naman, It is an abstraction that explains what data are stored and what relationships exist among those data. So yung information about the data type, is it a string, is it a date, is it a number, and yung structure, so meaning yung mga different columns na part ng isang relation, dito na define sa logical level. So, may tinatawag na physical data independence, which I will discuss in the next slide. Sabi dito is that regardless of the physical level or the physical how the data is stored in the memory in the physical level, hindi siya dapat nakakaapekto sa logical level. And then the highest level of view naman is the view level with multiple in this example we have view 1, view 2, and some view n. So sometimes one particular view may specific user na nag-access nito and hindi niya kailangang i-access yung lahat ng data dun sa database. Kasi for a specific user, ito lang yung concern niya. So it is also important to note that sometimes also important to note that sometimes yung mga view creates a cleaner security access right to the specific user. So, portion lang ng database yung nakikita nila. So, yung next naman is about instances and schemas. Okay? So, similar to types and variables in the programming languages. So, meron tayong logical schema, which is the overall logical structure of the database. So, the example is the database consists of information about a set of customers and accounts in the bank and the relationship between them. So, this explains yung logical view nung how the data is structured. And most of the time, this is the most important because regardless of the physical schema, hindi to nagbabago and the application developers only needed to know the logical schema. This is also analogous to the type of information of a variable in a particular program. So, yung physical schema naman is the overall physical structure of the database. It consists of saan naka-store yung actual data, yung mga data files, and ano yung type ng storage na ginagamit. And then, tinatawag na instance yung actual content of the database at a particular point in time. So, yung content ng database natin, it changes through time. So, at a specific parang time point, yung image na yon, that is an instance of the database. So, this one is analogous naman to the value of the variable. And then, yung mga structure na nandun sa view level, these are called subschema. And this schema describes the views of database. So meron tayong we could have multiple subschemas given a single database. Okay. So ito yung na-mention ko a while ago about physical data independence. Since we're dealing with three possible layers from physical, logical to view levels, the physical data independence is the ability to modify the physical schema without changing the logical schema. So regardless kung ano yung actual storage devices na ginagamit for the storage of actual data files, yung logical schema hindi siya nagbabago. And for the purpose of memory hierarchy optimization, hindi maaapektuhan yung mga applications using this database. So, Ano naman yung mga, as I mentioned a while ago, yung mga yung DBMS is composed of a set of programs for managing data. Ano naman yung language to instruct how to manage the data. And ito yung mga tinatawag na database languages. And yung marami pang other ways, pero yung pinaka-common is the SQL. Ay, actually, hindi ko alam. So yung next topic natin is about database languages. As I mentioned before, the database management system is actually composed of a set of programs. And yung set of programs na yon ay written in SQL or the SQL. And merong two types of languages sa SQL. Una, yung data definition language. Ginagamit ito to specify a database schema. So given a database design, you instruct the database management system na ganito ang itsura nung structure nung data mo. And then for the data manipulation language naman, this language is used to express database queries and updates. So for the data definition language, we use this to specify the database schema. One example is specifying the example a while ago. So for the instructor, diba, we have the ID, the name, department name, and salary. And dito naka-define yung data type niya. It is defined na si ID is a character na hanggang 5 yung symbol. Tapos name is a varchar or string hanggang 20. And then salary is numeric. So, yung DDL compiler generates a set of table templates stored in the data dictionary. So, yung makukuha natin from DDL is a data dictionary. So, ito yung it contains the information about the column names. So, ito yung mga other contents pa ng data dictionary. It contains data about the data, so information about the data. So, nandito nakalagay yung structure or yung database schema, ano yung mga columns niyan, ano yung data types. Some of the information like integrity constraints. So, ano yung primary key or the ID that uniquely identifies a specific in this case, instructor. And then, dito rin naka-define yung authorization or who can access who can access what. Okay, so yung second type ng language naman is the data manipulation language, which is DML. So, unlike yung isa, which is definition lang ng schema, this one is used for accessing and updating the data organized by appropriate data models. So, yung DML is also known as the query language. And then, meron tayong two classes of language, yung mga pure and yung mga commercial. So, yung mga pure languages, these are yung mga relational algebra, tuple relational calculus, domain relational calculus. These are formal languages that is used primarily for proving properties and limits of computational power. And hindi sila ginagamit for application development. Na hindi mo kailangang gamitin tong languages na to. But if you will develop an application na magki-query ng specific information doon sa database, you use the commercial languages, which is in this case SQL. And SQL is the most widely used commercial language for querying relational databases. There are actually two basic types of data manipulation language. Yung mga tinatawag na procedural, DML, and yung mga declarative DML. For the procedural DML, it requires a user to specify what data are needed. Since, diba, yung data manipulation language, we specify kung ano yung data na gusto na makuha ng data application from the database. For the procedural, we describe how to get those data. So parang it's the way how you will manipulate the tables so that you can get the actual data that you need. For the declarative DML naman, it requires a user to specify what data are needed without actually specifying how to get those data. But instead, it's a formal description of the data. So later, we will show some examples of the declarative DML. And to share with you, actually, mas madali nang ma-learn yung mga declarative DMLs than the procedural DMLs. And sometimes, these declarative DMLs are also referred to as the non-procedural DMLs. And yung mga portion of a DML that involves yung information retrieval is called a query language. So since we mentioned about the query language in the previous slide, let us introduce ano nga ba talaga yung SQL. So SQL is a non-procedural or declarative DML. So a query takes as input one or more tables or relations and always returns a single table. So hindi siya pwedeng mag-return ng multiple tables in a single query. So example is, let's say, find all instructors in computer science department. So we will explain yung mga select from and where in the next few weeks kapag didiscuss natin yung SQL. But the idea is you describe how you describe what data to get and by using the SQL query language. So you select the name from the relation instructor parang where the department name is equal to this string. So that's one example of an SQL query. So ang dapat i-return nito is one table consisting of only one column. So yun yung mga names in the instructor table. So what's important is to note that SQL is not a Turing machine equivalent language. So, hindi pwedeng mag-isa lang si SQL tapos comparable na siya sa Python, sa C, sa C++, sa Java, and so on. So, hindi niya kaya yung gawin, lahat ng kayang gawin ng Python or ng other Turing machine equivalent language. So, to be able to compute complex functions, si SQL, it is usually embedded in some higher level languages. For example, yung mga SQL query natin, sometimes nilalagay siya sa loob ng mga C, Python, or Java na codes. And yung application programs, it generally accesses databases through one of the language extensions to allow embedded SQL. So, minsan gumagamit ng application program interface or APIs. May mga connectors, yung mga application program mo, let's say written in Java or Python, connected siya, ay gumagamit siya ng tinatawag na mga connectors, itong ODBC for mga open database. And then meron tayong mga JDBC naman, connector for Java applications. And it allows SQL queries to be sent to a specific database. Okay. So, yung database access from application program. So, yung mga query language such as SQL, since I mentioned a while ago that these are not as powerful as a universal Turing machine, SQL does not support actions such as input from users, output to display, or communication over the network. Yung mga ganong programs, ini-implement siya using other languages. And then, such computations and actions, yun nga, ay tinatawag gamit yung host language, katulad ng mga languages nito. And then, meron lang SQL code inside those language na pwede kang mag-embed. So, yung mga application programs natin, na written in other languages, they perform other computations and then if they needed the data, they call the DBMS using some connector, ODBC or JDBC, to retrieve information. And for example, if the computation is done, sometimes they also store those information to the database. Okay, so since we're talking already about relational databases, and na-mention ko din a while ago that we have actually a DDL, or a language specifically designed uh, to define kung ano yung magiging structure ng database. Meron din tayong dapat pagdaanan, which is the database, designing the actual database. So in designing the actual database, we need to identify the general structure of it, dun sa mula sa physical design up to the logical design. So ang kailangang i-decide is on the database. So the logical design, the output here is the database schema. And then the database design requires that we find a good collection of relation schemas. So, yung good collection of relation schemas, dictated siya ng players nung pagde-design ng database. Yung mapoprovide ng business decision is that ano yung mga information or attributes that we should store in the database. Sa computer science decision naman is that ano yung mga relation schemas should we have, and how should the attributes be distributed among those various relation schemas. So it always starts with what attributes, kung ano yung i-record sa database, and then yung computer science naman, ang gagawin niya is how to organize those attributes na gustong i-store depending on what type of application will be using those information. And on the physical design naman, we need to define the physical layout of the database. What specific type of storage we will use for for storing those database files and so on. So sometimes sa physical design, it's also important to know the different architectures that we can use for the database design. Okay. So the database engine, okay, is actually partitioned into modules, and each module is responsible for the overall system. So I mentioned a while ago that the DBMS is also a collection of programs, and yung collection of programs na to ay part ng mga different modules. So meron tayong three main modules. So yung storage manager, the query processor, and then the transaction management. In the three modules ng DBMS, yung ginagawa ng storage manager is it manages yung actual storage. So hindi siya ganun ka-trivial because most of the time we use database to store large amounts of data. And then we need sometimes the actual physical storage or pieces na maliliit lang yung capacity, and then gagamitin yun to store a larger information. Yung query processor naman is necessary to simplify and facilitate yung pag-access ng data. So tuwing nagkakaroon ng specific DML, yung query processor yung nag-handle kung paano niya kukunin yon sa database. And then for the transaction management, necessary naman siya so that we can ensure that all operations are atomic. Okay. So for the storage manager, a program module, this one is a program module that provides the interface between low-level data stored in the database, and the application programs and queries submitted to the system. So the storage manager is responsible to do the following task. So interaction with the OS file manager, because at the lower level, parang database files pa rin yung involved. Meron ka lang layer na nag-organize nung files na yon, which is the role of the DBMS. The storage manager ensures na efficient yung pag-store, retrieve, and pag-update ng data dun sa mga different possible locations ng data. And yung ginagawa rin ng storage manager is to ensure na may tama yung access or yung authorization ng person or ng user na gustong mag-access ng data, and that it ensures some integrity constraints and so on. So this example is showing you how a particular application program can call yung storage manager. So I mentioned a while ago na pwedeng yung actual physical storage nito is composed of multiple smaller disks. So meron tayong mga types ng disk, may mga, let's say, mga faster storage devices like SSD na may mga different capacity. And then meron tayo ng mga mas malalaking capacity, mas cheaper pero mas mababagal. So the storage manager takes yung responsibility of storing it to appropriate physical storages. Okay. So, ano yung mga okay. So, yung storage manager, it also implements several data structures as part of the physical system implementation. So, yung mga actual data files, ito yung mga storage files ng mismong database itself. And then, siya rin yung nag-implement at nag-maintain ng data dictionary, which stores yung, of course, metadata about the structure of the database. And then, siya rin yung nag-maintain ng indices. Indices or the actual location of data files in specific physical storages. So, these indices are also used for fast access to specific data items. So, similar to hash tables. Yung second component is called the query processor. Sa query processor naman, it is composed of three parang submodules. And yung submodules na to, gumagawa siya ng may very specific purposes. So yung first ay yung interpreter. So yung query interpreter ay ang ginagawa is given a data definition language. Ang ginagawa niya is ni-interpret niya yun so that it can create the data dictionary. And then, yung mga SQL naman na data manipulation language, for example, given a query language, dumadaan yun sa compiler module, and then it creates a set of low-level instructions na ini-implement ng evaluation engine. So, yung evaluation engine natin, yung mismong execution, kung saan ina-execute yung mga low-level instructions given a particular query. And then the last module is the transaction management. So definition lang, a transaction is a collection of operations that performs a single logical function in a database application. So, yung transaction management component, it ensures that the database remains in a consistent or in a correct state despite nagkaroon ng system failures. So, to recall, may mga tinatawag tayong mga atomic operations. So, the transaction management ensures na tong tatlong items na to ay nangyayari. So, all operations ay all or nothing. Tapos, we can also make sure that the data, regardless kung mag-fail siya or something, consistent yung kanyang state. Ibig sabihin walang inconsistencies doon sa mga multiple tables natin. And then, kahit mamatay, let's say, yung at nag-fail, nandun pa rin yung data at hindi siya mawawala. So, yun yung tinatawag na durability. Ngayon, si transaction management, may ginagawa siyang isa pang bagay, which is yung concurrency control. Yung concurrency control, it controls the interaction among concurrent transactions to ensure na regardless kung nag-implement yung nang sabay-sabay itong mga different operations na to, walang magiging inconsistent dun sa data. Meron tayong two types of architecture, yung two-tier architecture and the three-tier architecture. I think on the next slide, mas ma-differentiate natin yung dalawang types of architecture. In this case, meron tayong drawing ng two-tier and then meron tayong drawing ng three-tier architecture. For the two-tier architecture, yung application mo, which is on the client side, it connects through the database system using the network na nasa server side. And then, kapag three-tier architecture naman, yung application mo is composed of two parts. Meron kang application client na nasa client side, and then meron kang application server na nasa server side. Okay. So, sila yung nag-uusap, and then the application server requests for connects to the database system in the server. So, ito yung main difference ng two types of architecture. So, we will also discuss ano ba yung mga users ng database natin. There are actually 4 different types of database system users. Meron tayong mga naive users. And most of the time, mga naive users yung gumagamit ng databases. Sila yung mga quote-unquote unsophisticated users who interact with the system by invoking one of the application programs that have been written previously. So, sila yung mga users ng web applications na nag-access ng data through the applications na gawa na. And then, may mga application programmers. These users are computer professionals who write application programs. So they need to know the logical schema of the database so that they can, or at least the sub-schema, for them to be able to know what are the available information that they could use in the data application. Meron tayo ding mga tinatawag na sophisticated users. So yung mga sophisticated users, they interact with the system without writing programs. In fact, they're using database query language or using tools such as data analysis softwares. So sila yung mga usually gumagawa ng mga sub-schema for further processing. So sometimes yung mga processing procedures na yon are data analysis software like visualization, minsan pwedeng additional machine learning techniques, etc. So yung mga sophisticated users natin, they should also know kung ano yung logical schema na dinefine ng database manager or administrator. So, meron din tayong mga tinatawag mga specialized users. So, ito yung mga hindi usual na database application. So, sometimes sila yung mga gumagamit ng nag-i-store ng mga information like CAD data, graphic data, audio, and video. So, ito yung mga main database users. Pero ang pinaka-important sa given database management system is the database administrator or tinatawag natin DBA. So, this person has the central control over the system. And yung mga ginagawa ng DBA is the schema definition. They are also in charge of restructuring yung storage and identifying yung mga access method definition. What else? Yung mga physical organization modification, depending on the architecture, granting or parang authorizing other data users for data access. So they give permissions to different user roles. They also do the routine maintenance to check periodically kung na back up ba yung system, kung ano ba yung utilization ng system, to know kung may gagawin ba silang some improvements on the database architecture, or they will allot more storage device. And then, they also ensure na enough yung free disk space para hindi magkaroon ng denial of service for normal operations and for upgrading this space as required. So they monitor jobs running on the database and ensuring that performance is not degraded by very expensive tasks submitted to some users. So, ito na yung last part, the history of the database system. So, it started 1950s pa and 1960s. So, yung ginagamit dito palang na computers are mga punch cards pa for programming and for storing input, and they are using magnetic tapes for storage. Nung late 1960s and 1970s, hard disk allowed direct access to data na. So, they are also using network and hierarchical data models in widespread use. Noong 1960s and 1970s, dito rin na-imbento ni Ted Codd yung theoretical model ng relational data model. And with this result, nanalo siya ng ECM Turing Award for this work. And then, dahil nga nagkaroon na ng theoretical basis for commercial use, dito din nag-start ang IBM research and nagbigyan sila ng kanilang system or na prototype. So dito na nag-start na ma-commercialize ang database. And kasabayan nito sina Oracle na mag-produce ng commercial relational databases. So dahil nagkaroon na ng kick sa industry, ng utility yung high performance transaction processing. So ito yung mga financial systems, sila yung mga unang nagkaroon ng database management systems. Noong 1980s naman, nagkaroon ng standardization sa industry. And dito na nagkaroon ng limitations due to high performance transaction processing. Nakita nila yung limitations ng paggamit ng single core or shared centralized databases in enterprises. That's why nagkaroon na ng parallel and distributed database systems. And then, na-invento rin yung object-oriented database system noong 1980s. Noong 1990s, nagkaroon ng dito na introduce yung other mode of usage for databases. So since noong 1990s, nagkaroon na ng decision support systems or mga database applications na obtain ng data and then nagpo-process ng data for the purpose of mining useful information for enterprises. So, noong 1990s din, nagkakaroon na ng ganito kalaking database size. So, yung multi-terabyte na data warehouses. And then, nung nagkaroon na rin ng existence ng mga web commerce.
So, noong 2000, nagkaroon na ng challenge called the Big Data. And it is driven by the fact that iba-iba na yung format ng mga data types. And hindi na lang sapat yung SQL to model the content of the database. Because of this, semi-structured data became very important. So, yung mga compact data exchange formats like XML and JSON, ginagamit na siya to store information like spatial data or yung mga data that includes geographical information and those data that are coming from social network platforms. So, because of this social network platforms, doon din na-develop yung tinatawag na graph databases because it's very important for social networks to maintain the connection between entities or between nodes. In the latter part of the decade, the use of data analytics and data mining in enterprises became very important. So, nagkaroon ngayon ng mga database systems that are very particular to this specific purpose. Yung mga systems na to are column stores. So, hindi sila yung mga row-oriented storage but column-oriented storage because majority ng mga data for data analytics ay wide yung tables. Yung majority ng composition ng big data comes from textual or semi-structured. And since we're dealing with a huge amount of those types of data, it led to the development of frameworks that will allow massive parallel applications. So, ito yung tinatawag natin na MapReduce. So, yung context ng NoSQL, before, they are not really capable of doing SQL-based queries, but at the moment, not only SQL yung kaya niyang i-handle.
So that's the end of chapter 1. Our next session, we will be focusing on relational model.